All right, here we go. So 7.1, inverse. Okay, so I need you to go back and I need you to remember that we already kind of did something similar to this last year. And we called it direct variation. Okay, and direct, and I need to bring that back again because now the challenge is going to be to recognize is a direct variation, is an inverse variation, or is it neither of those, okay? So I want to go back and write the formula. Direct variation was y is equal to ax. Does that look familiar? Kind of? Okay. Was way back in the day. And one of the things, notice if this is y is equal to ax, which by the way, when you go to, we have been doing that on our calculator and you go to exponential reg, you notice that linear reg says y is equal to ax plus b, okay? But there is no b. So that means that every direct variation goes through what point? Do you remember this? 0, 0 goes through the origin. Awesome, good job. So it doesn't have a y-intercept, okay? So we have used the word inverse though in the past. And what does inverse mean? Flipped, right. And so, okay, this is inverse. So notice that we flipped. The x is on the bottom. Okay. Do you remember what the A actually stands for? Okay. Yeah, that's right. It is. It's the rate of change. Okay. And the rate of change, which by the way is constant. Okay. That is a constant. So it's that value. So when we were doing direct variation, we were actually going back and finding like the equation. We're going to do the same thing with inverse, but keep in mind, this is how, so direct variation, as one goes up, the other goes up. It's a direct variation. Okay, the more you study, the higher your grade. The more you work out, the higher muscle content that you have. Okay, but is working out also an inverse variation? Yeah, actually, for a lot of people, it can be, because some people work out and their weight goes down. Okay. Or how about the more that you work out, the less body fat you have, because you're replacing it with muscle, right? Okay. So that sort of relationship, that is the inverse relationship, which actually applies to lots and lots of things. Okay, especially like there's lots of physics concepts with that inverse variation, lots of things. As one goes up, the other goes down. Okay, questions on, so for example, the lower you go under sea level, what happens to your pressure? It goes up. See what I mean? So it's totally different. Okay, so we want to practice, we're going to practice it kind of in the same way with direct, but the first thing we're going to do is see if you can recognize, is it direct variation or is it inverse variation? So the one way that you need to do it is to get it set equal to y so that you can actually see what it looks like. So here's your examples. All right. Is this direct? Is this inverse? So let's get it written so that we're y equals, okay? Okay, multiply by 9. So instead of dividing by 9, multiply by 9. What I do to one side, do to the other, and I'm left with y is equal to, and I always put the number first, then the x, which you probably did and didn't even think about. Okay, which one is that? Direct, done. But when you started looking at it at first, it looks kind of inverse-ish, doesn't it? With that number on the bottom. Okay, solve for y. Divide by x. What you do to one side, do the other. Y is equal to 3 over x. Inverse. Solve for y. Wait a minute. It already is. Direct or inverse? Or neither? It's neither, right? I can't have a plus. That doesn't work. Nope, because 2 and x are not like terms. Nope. All right, I'm going to give you, so I'll give you another one. What do I want to do? I want to kind of. What was that? I heard divide by 3. Be careful. I'm glad I did this. Careful. Careful. Is it inverse? Okay, but wait a minute. What's the number in front of the x though you don't see it?
1.
It's 1. So could you rewrite this as y is equal to 1/3 x? And then what is it? Is it inverse or is it direct? It's direct. It's direct. It's the location of the x. Watch. If the x is on the bottom, then it's inverse. Okay, so just be careful. The number was on the bottom, not the x. Okay, now remember how I always said something and we'd be, oh, it's to this power, we have to throw it in the basement. Do you remember what makes something go to the basement? What power? Ooh. I think I heard it. Negative. A negative makes it go to the basement. Okay? A negative. So when you have on your calculator, x, friends, right here, the x -1 button on your calculator, that's the inverse button. That takes any number and flips it over itself. So think about it. The x is flipped over itself. Okay, so our big thing is now we want to take, just like we did with direct, and we want to take, and I'm going to give you a set of points. I want you to figure out what the constant is so you can write the equation. Okay, blah, 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 blah. Okay, here's what I mean by this. So the question is going to be written kind of like this. The variables x and y vary inversely. Okay, x and y vary inversely. Meaning, hey, which equation should I use? The inverse equation. You're like, duh. Okay. Y is 3 when x is 6. Okay. It goes on to say, find y when x equals -9. That's how the equation is written. This is what you need to do. Okay, and we talked about this with direct. You need to ignore this piece and get me the equation first. So you need to take this set of numbers here and figure out what your constant, figure out what your slope is first. Okay, figure out what this a is. Okay, y is equal to a over x. Let's see. Plug the y in for the y. Plug the 6 in for the x. and solve for A. 3 equals A over 6. So is that the way it's going to be every time? Yes, you can literally cross multiply. So A is 18. Stop and write the equation now that you have found A. Now it sounds like I'm getting angry. I am, because I keep telling people to do this, and then you can plug in anything you want after it. But you need to come up with an equation that you can use for anything. So y equals 18 over x. Box it in. Now you can come up with any values you want for x, and they are super easy to find, right? So, okay. Now, y equals 18 over x, and instead of x, we want to know what 18 divided by -9 is. What is that? -2, and you're like, I didn't even have to write that out. You know what? You don't have to. But you do need to figure this. And then you could do this on your calculator, super easy. I could give you a whole set of numbers, and it would be super easy to put in once you come up with the equation. Okay? Questions on that? All right, so let me give you one to practice. Okay, y varies inversely. So we're going to use y is equal to a over x. Y is 4.4 and x is 5. Write the equation and then find y when x is 8. Okay, go. Sure, you can blow your nose. Have a good trip. Hope everything comes out. All right. Yeah, don't tell us the color. We don't want to know. Okay, here we go. I've had doctors tell me that doesn't matter, and I was like, really? Because every time mine is colored, it always ends up being an infection. Did you find a Kleenex? Yeah. Oh, okay. Oh, okay. Here we go. You need me to color code. I'll color code real quick. Forgot what I already color coded. Yellow, and for yellow, and blue, and for blue. All right, and what's 5 times 4.4? 22 even? All right, stop and write your equation. You with me there, Schleckbeer in the back? Okay. Y is equal 22 over x. If you don't have y is equal to 22 over x, you need to. Okay, you need to have an equation. It's not just plugging in numbers. You have to have a y and an x, and you have to have the a figured out, because then I could give you any value I want for x. And in this case, we're plugging in 8. So what's 22 divided by 8? Done. Okay. So here's what we're going to do. This is one of the challenging parts of this section. Okay, I'm going to give you a set of points. Okay, I want you, okay, we're going to work on finding, is it direct? Is it inverse? And if it's either one, we have to find the equation for it. Okay. So remember, our choices are direct, inverse, or neither. Okay, before you go crazy doing any work, you need to look at the numbers and tell me what's going on with the numbers. What's happening to the x values? They're going up by 1. What are these going? Are these going up or going down? These are also going up. If both of them are going up, our first indication, can we eliminate anything? I can eliminate, it's not inverse, right? Inverse is one goes up, the other goes down. So it's not inverse. So we got to see if it is direct. Okay. So it could be either direct or it could be neither. Okay. So one of the things about direct, and you told me this is the slope, right? If I solved for A or got A all by itself, that just reinforces what we know about slope, right? Slope is rise over run. Is there a constant rise over run going on? So what is y divided by x? 2 divided by 1 is 2. 4 divided by 2 is 6 divided by 3 is 2. 8 divided by 4 is 2. 2. You just found A. If it is constant all the way across, then it is safe to say, you know what? There's my equation. I just figured it out. Okay. Go, Ethan.
Could you just plug in like a set of points for y and x?
You could, but here's the thing, Ethan. You want to make sure, you have to make sure it is constant. So if you just put in a set of points randomly without checking this piece down here, it might not go up constantly. Okay. So we have to really check. All right, let's try this one. All right, what's going on with X? What's going on with Y? X goes up, Y goes up. So it's either direct or neither. Okay. So let's check. We just talked about that if it's direct variation, I know that A is all about the slope, which is rise over run. Do you see how I set that equal? Okay, let's see if it's constant. 6 over 2 is 3, but 7 over 3 is not. So guess what? It's not direct. It doesn't go up at a constant rate. Okay, what's going on with X? X goes up, but Y goes down. So my choices are either inverse or neither. All right. Now, you know how we looked at A? And A was the slope for direct. Look at what happens if I get A by itself. How do I get A all by itself? Oh, so the relationship between X and Y is not a rise over run, it's a multiplication. So what happens when I multiply these two together? 2 times 5 is, what's 4 times 2.5? What's 4 times 2.5? Oh, that's 10, thank you. What's 8 times, what's 1 times, aha. What did you just find? Okay. It's not, and the weird part is these graphs, it's not, you can't really call it slope necessarily, but that constant, you're right, is 10. Good job. Here's why. Okay, here's why. Direct variation. All right, so let me show you on my calculator. Okay, give me a let's see. We were y is equal to 2x, right? Okay. Hold on. Let me make sure my window is all weird. Okay. Here we go. Here's y is equal to 2x. Okay, straight line, right? Okay. Look what happens if I put x in the denominator. Whoa. Whoa. It's a totally different graph, isn't it? Do you remember way back when we were looking at, is this linear? Is it a straight line or is it not a straight line? X has to be at the top. It's got to be to the first power. It can't be it can't be up in the exponent. It can't be, that's what we're talking about. The minute it goes to the basement, now we're like this weird curvy thing going on. That's what the inverse of X will do. Okay. And it looks like it. So say, for example, if I cross this out, what does just that curve look like? Have you graphed something like that? What is that? That's exponential decay. Very good. Excellent. Okay. That's exponential decay. And notice it is just opposite. It's mirrored between these two quadrants. Do you think that always happens? How do you think you can flip it to go to these quadrants? Switch the signs. That's right. Make them negative. Absolutely. Good job. See? You guys got that. Good job. Excellent. Okay. All right. So that is all about, well, let me give you a few more. Let's practice a few more. Okay. You better make sure. All right, try those two. Go, go, go. All right, you got 3 to do. Okay, here we go. All right, what do you think? First one, direct, inverse, neither. Okay, so you're telling me this one goes up, but this one goes down. All right, so if it's y equals a over x, and I'm wanting to look at my a, then I'm going to take and see if I multiply these two together, is it constant? Is it?
Yeah.
It is. I believe it's 2, right?
Yeah.
So y is equal to 2 over x. Done. Okay. Okay, what's going on with this? X goes up, y goes up, so we have to check. It might be direct or neither. So let's see. If I look at the a, the relationship between that is y over x, so slope. So 1 over 3, 1 over 3, 1 over 3, 1 over 3. How do I write that? 1/3 x. Good. Why? Oh, say it again.
Like you went 1 over 3, 1 over 3, 1. Yeah. Okay.
Sorry, I didn't reduce that. I'm sorry. It does look goofy. Yes.
So you would divide y by x, right?
Yep. Okay. What's this one doing? Up. What's this one doing?
Going up, but it's
Up?
random.
Okay, so is it, oh, Isaiah's saying it's random. So 1 divided by 1 is 1, 4 divided by 2 is boo. Right, doesn't work. Okay, there is one more type of variation here, and I like this one because you definitely use it in physics, and it's called joint variation. It's a type of direct variation, but there are multiple values, okay? There are multiple values that are used here. What?
Top one, 0.5 divided by 4 is 8. Or 4 divided by
We're not dividing. Watch. So do you see how this one goes up and this one goes down? Okay, so if I'm looking at inverse, look at the relationship between the x and y. You have to multiply. Okay? No, I think that's a great, okay? So you have to multiply x and y together. Okay? No, that's good. Thank you. That was a good one. All right, so here's your equation for this. Z is equal to ax and y. Okay? Notice that the only difference between direct and joint variation is that there's just another variable, which means there's multiple variables involved. Okay? But it's still the same thing. It's still easy. Absolutely. So here we go. I'm going to tell you that the variable z varies jointly with x and y, and that z is negative 84, x is negative 4, and y is 3. So what do you think you need to do? Plug them in.
Not that easy.
It's that easy. Really. So what did I use? Did I use yellow for x and orange? Huh? Did I?
Yeah, you know.
Well, now I got to use orange because I got Z. There you go. Plug it in. Notice the only one that's not colored is A, because you got to find A. All right, go. I tend to put mine in parentheses just because it makes it easier. Right? Negative 4 times 3 is negative 12. Divide by negative 12. And I get 7. Okay, rewrite the equation. Oh, not y. Z equals 7xy. Because now I can give you new values. All right, so find Z when x is 5 and y is 2. Go. Hmm? Yes, A is still 7. Now use this equation. So if you're like, wow, that was really easy, it should be. Because I'm literally just plugging them in to my calculator, right? And multiplying them through. So what do you get? 70, done. That's it. And the whole idea of joint variation is when you get multiple variables going in to multiplying and getting something. So if you stop and think about if you were to take the radius and something else, or the length times the, and you're getting multiple variables. That's all you're doing here. Okay. All right, here's the last thing. All right, let's see if you can write the equations for me. So I want you to write them one more time up at the top. Here's direct. Okay. What's this one? Inverse. And this one is, okay, this is joint variation. All right, so here we go. Here's number one. I want you to write the equation. M varies jointly with N, P, and Q. Okay. All right, yep. M varies jointly. So how can I plug this? So first of all, which one should I use? Joint. Okay. The letter that is mentioned first is the, right. So M equals the letter that will never be mentioned that you have to put is the A. So you have to put an A in. Okay. And then what should I do with N, P, and Q? Just put them at the end. All right. And we'll finish up next week. Good job, everybody.
Can I put my quiz